I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up applications of derivatives. Specifically, we'll learn about rate of change concepts and strategies to solve word problems. 5 examples will be discussed in details. The questions are shown here and will grasp the effective strategy in solving such problems. You can master the strategies and succeed, and also develop critical thinking skills by joining my classes. Stay ahead of the competition and achieve your objectives. Hi Akshat, how are you doing?
Hi, sir. I'm great. How are you?
Very good, very good. You had a test recently, right?
Yes, sir. I just had it yesterday.
How did you do?
Sir, I did pretty well, actually. I finished 45 minutes early.
45 minutes early? How long
Yeah,
was the test?
the test was for 75 to 80 minutes.
Oh, I see. That's good. Okay, then.
And then, sir, I actually wanted to discuss two questions with you.
Sure. Yeah, see. What are the
Right.
two?
So, sir, the first question was that we were given a quartic function,
Mhm.
and we were given another line, x equals to -6, and
Mhm.
we had to find tangents, plural, which have perpendicular slope that pass through that curve and
Correct.
perpendicular to the line.
Good question. Let me share a whiteboard and then we'll discuss. Is that okay?
Yes, sir.
Correct. So you are sharing a test question, right?
Yeah.
Test question. It is a challenging question. So again, tell me, what is the question?
Right, sir. So there was a quartic function,
Okay.
and we were given the line x equals to -6.
Let's say this is my quartic function, okay? You are given a
Right.
line x equals to -6.
Yeah,
Means it is a vertical line, something like this, right?
exactly.
X
And
equals
we have to find tangents that are perpendicular to that line that pass through the curve.
that pass tangent to the curve, right?
Yes, tangent to the curve. Yeah.
So that could be a tangent. All the turning points, do you see?
Yes, sir.
Could be the tangent. Do you see that?
Yeah.
So you have a vertical line given and a quartic function. You could expect maximum 3 turning points on the quartic function. It could open down or up, depending on your equation.
Yeah.
So basically, if the function is f of x, you need to find the derivative of the function and equate that derivative to 0, because
Yeah.
perpendicular to the vertical line will be any line with slope of
0.
0. And that should give you probably 3 answers. You get the idea. So at
Yes, sir. I
one
got 3
point,
answers.
it will be giving you that image. So that's a good question. And
Yeah.
that is how you could visualize the solution. Okay. Yeah. Second, any other question?
Yes, sir. The second question was that we were given a polynomial function.
Okay.
I think the total degree was around 7 upon expanding. And we had to find the maximum number of horizontal tangents that were possible.
You said after expanding, was it given in the factored form?
Yes, sir. It was given in the factored form.
Why did you expand it?
Sir, I didn't expand completely. I just checked the highest degree. That's what I meant. Like, because
okay.
yeah, one factor was squared and the other was like that. So I just expanded to see the highest degree and then added them together.
I see. Okay.
Yeah.
So again, what was the question? Polynomial degree 7 was given to you then?
And what are the maximum number of horizontal tangents?
Maximum number of horizontal tangents. That really means what?
Where are the slope of the tangent 0? So basically referring to the turning points.
Perfect. Basically, you're referring to turning points.
Yeah.
So if it is degree 7, then you have 7 minus 1 turning points, right? So 7 minus 1 turning points, let me write TP. So you expect 6 points where the horizontal will be tangent, right? But now,
Yes, sir.
This is one answer in general.
Yeah.
Maximum. This is maximum. I think the question you are saying maximum number of, right?
Maximum, correct.
But now, let me change this question. And you said you also said that you were given in factored form, right?
Yes, sir. In fact,
And one of them factor had 2, degree 2, right?
yeah, degree 2.
So let's say x plus 1, degree 2, x plus 2, x plus 3, x plus 4, x, let me write all plus. General, right? 1, 2, 3,
Yeah.
4, 5, 6, and then also x plus 6, right?
Yeah.
1 is degree 2. So what is the degree of this function?
Degree 7, sir.
So if you sketch how many turning points will this have?
A maximum of 6, sir.
No. Say 1, 2, 3, 4, 5, 6 zeros, right?
Okay, yeah.
And see, I'll just sketch it for you so that you understand what
Yeah.
happens with this specific person. I mean, I've taken purposely all the turning points in the sequence,
Yeah.
negative, right? So we'll go here, right, on this side. So let me just erase this because I took them on this side. So we have, so we have one as -1, then we have -2, -3, -4, -5, -6, right?
Yeah.
And is opening upwards. So degree 7 is going upwards. So here it turns. Do you see it turns?
Yeah, like a parabola.
Do you see the function? So
Yes, sir.
turning points, if you are given factor form, you don't have to open. That's what I'm trying to say.
Yeah.
1, 2, 3, 4, 5, 6. So you see it is still 6 because 1 turns there itself. You get the idea?
Yes, sir.
If I change this question and I make this as 3, then there will be less number of turning points because then
Yeah.
we'll have one kind of like this. So your question was, you were safe actually in getting the
Yeah.
correct answer. But in case they give you the factored form, remember, you have to actually see how many turning points are there, right? You
Right, sir.
remember the turning point formula? Number of
Yes,
zeros,
sir.
-1 plus number of even zeros.
Okay.
You had
I'll
one
actually write
even
this
zero,
down.
therefore you get 6 turning points. You get the idea? And
Yeah.
your answer is correct. Good job. Okay, today what do you want to do?
Sir, today I was hoping we can start with the application of derivatives and build upon what we've already learned in derivatives.
Sure. So I'm taking a very interesting question on application of derivatives.
Yeah.
You'll find many test questions in this particular video which are related to application of derivatives. Let me
Yeah.
share with you our lesson.
Okay.
It's a very beautiful lesson. So can you see my screen, please?
Yes, sir. Perfectly.
Okay, it says application of derivatives, related rates. So related rates means we are now, let's say you're walking along the x direction. So the rate of change will be dx dt. You get the idea?
Yeah.
So we could have related rates means more than one thing involved at the same time. So related to one
Okay.
another could be the case. So
Yeah.
these are real practical situations and very good examples which are solved using derivatives. So
Yeah.
application of derivatives, related rates, extremely important chapter for all of us. Okay, so here are a few key points which we are going to look into. Can you please read the screen?
Yeah. Related rates problem solving strategy. In related rates applications, rate of change of one quantity is given, and we are interested in finding the rate of change of a related quantity. First step to solve these problems is to identify what is given, what can be derived, and what is required. Then, find the equation that relates the two given quantities. If necessary, eliminate one of the variables. Apply the chain rule to differentiate both sides with respect to time. Solve for the unknown rate by substituting the results obtained, and write solution including units.
So that is the key step to find related rates. I think you've got the concepts right. When
Yeah.
you see the questions, you will understand what exactly we are trying to say here, right? So
Yeah.
here are 5 questions for you. Can you please read the question?
Yes, sir. Question 1. A pebble dropped in a pond produces waves that spread at a constant rate of 1.5 meters per second. Find rate of increase of area of the circle when the radius is 10 meters.
Correct. Do you see the two things related clearly, right?
Yeah.
So what you need see here is that if I drop a stone, you'll see the ripple. Do you see the ripple?
Yeah, the ripple.
Over time, this is going to grow, right? So
Yeah.
it's going to grow. So a pebble dropped in the pond produces waves that spread at a constant rate of 1.5 meters per second. So this is spreading, and this rate we can say dr dt, right? With this radius is increasing, right? And
Oh,
this
okay.
rate is 1.5 meters per second. You get the idea?
Yes, sir. Got it.
Find the rate of increase in area because they spread. Like so,
Yeah.
I could actually relate it to many practical questions. For example, oil spill. You get the idea.
Yeah.
As soon as there is an oil spill, we know that after 2 hours it is going to reach the shore
Yeah.
because you can work it out, and you
Right.
also know how much area will be affected by this spill. So that is a
Correct.
direct calculation on the loss of natural life, right?
Yeah.
Or even the cost of recovering all these things. You get the idea. So
Yeah.
it plays a huge role. So very simple question. A pebble dropped in a pond produces waves that spread at a constant rate. This rate is constant, 1.5. Find the rate of increase of area of the circle when the radius is 10. So when r equals to 10, you have to find dA dt.
Yeah.
So we have related one thing with the other. So that is the whole concept of this particular unit. Very practical questions are there. All the
Yeah.
questions are like this. So you have understood. We will do this question soon. Can you please read the others?
Yes, sir. The volume of a spherical snowball of radius r is v equals 4 pi r cubed over 3. A snowball is melting such that its radius is decreasing at the rate of 0.025 centimeters per second. Find the rate of change of volume with respect to time when the radius is 2 centimeters.
Correct. Very similar
Yeah.
to the previous question. In this case, the whole volume is decreasing because melting snow and the snowball is melting. So it relates the
Yeah.
two things. We have given you the formula volume of a sphere, well known, 4 by 3 pi r cube. And if you find the derivative, it will be the surface area, right?
Yeah, it
4
will be
pi
the
r
surface
squared.
area.
So we know the surface area, and I think you can now solve the question, correct? Okay, question
Yeah.
number 3, please.
The surface area of a sphere of radius r is expanding at the rate of 0.05 centimeters per second. Find the rate of change of area with respect to time when the area is pi centimeters squared.
Where the area is pi centimeters square, right? So
Yeah.
that is a very similar question, but you get the concept of related rates with these questions. That's the whole key, right? Question number
Yeah.
4, please.
Tap is filling water in a container at the rate of 240 centimeter cube per second, and the level rises at a rate of 0.8 centimeters per second. How fast is the volume changing for each centimeter increase in the height?
Excellent question. The tap is filling a water in a container at a rate of, we have given the rate at which the water is filling in the container, right? And the
Yeah.
level is rising. Obviously, if you fill something, the level is going to rise. And at this rate. So you can say height is my parameter of level rising. So dH dt is given to you, right?
DHDT. Yeah.
And when we say filling means volume is given to you. Even the unit centimeter cube tells you
Yeah.
dV dt. So in these questions, you have to look at the unit and see what is the parameter. So volume, because it is centimeter cube per second, dV dt. So we have
Yeah.
given you change in volume because the volume of water filling in the container and change in height, which is linear. I mean, linear means centimeter per
Yeah.
second. Uh, that is how the question is to be treated, right? And we are asking, how fast is the volume changing for each centimeter increase in the height? So both the
Right.
parameters are explicitly cleared in the last statement, but you get the
Yeah.
concept, you get the idea.
So, sir, you can just look at the units for the values and then
Yes.
basically use the Leibniz notation for them, right?
Look at the units. If you have a
Yeah.
word problem, look at the units. And let me tell you one thing.
Yeah.
Sometimes I'm saying, what is the rate at which the height is increased? Let's say volume is increasing with radius.
Yeah.
So volume will also have the same unit of length. Radius will also have same unit of length.
Yeah.
This is centimeter and
Yeah.
centimeter cube. In that case, in the answer, your unit has to be centimeter cube per centimeter.
Per
Do not
centimeter. Yeah.
cancel them
You
and do
can't
not write
cancel. Yeah.
centimeter
Yeah.
square. It will be like no sense. Do you understand?
Yeah.
So
Yeah.
do not cancel the units. This is very important and key thing to understand. We are
Yeah.
changing the volume with height. So in that case, volume units, centimeter cube, and the height unit, centimeter should come. Do
Yeah.
not simplify the units in this
Yeah.
regard. Okay. Last
Okay,
question,
sir.
please.
Water is being pumped in the circular cone-shaped tank at the rate of 1.8 meters cubed per minute. This 5-meter high tank has 6-meter diameter at the top. Find the rate at which the water level is rising when the water is 2 meters deep.
Correct. So another very interesting. So we have a cone, circular cone shape means you understand it is like this, right? This is our tank.
Yeah,
That is what we are talking about. So in this tank, we are filling in the water. Let's say what is being filled in this tank, being pumped into a circular tank at this rate, 1.8 meter cube per minute volume. This 5-meter tank has 6-meter diameter. So we have given you the dimensions of the tank, right? So this
yeah,
5-meter tank has 6-meter diameter. So this is 6 meter and this height is 5 meter, right?
yeah. Yes,
At the
sir.
top, right? Find the rate at which the water level is rising when the water is 2 meter deep. So when the water is 2 meter deep, at this time, at this instance, you have to find the rate of change in height. You get the idea?
Yes, sir.
So volume is 1 by 3 pi r square inch. So cylinder 1/3, correct?
Yeah.
And then you can relate one variable with the other. And whenever you have H and R, right? So you can have similar triangles. Do you see that?
Oh, yeah.
So you have to see how are we going to relate one parameter as the other. So I have top, I'm already given, right? I know this is half 6, this is 3, right? 3 and
Yeah.
5, correct? So I know big triangle. I don't know what is this at instance of R and H, but I have related R and X, right? I'm
Yeah.
saying 3 over 5 is R over X, right? So I'm saying 3 over 5 is R over H. And since we are interested in finding the rate at which the water level is rising, when the water is 2 meter deep, means height. I have to
Yeah.
eliminate R. So I'll say R is what? 3/5 of height is R. So from the equation, I'm going to
Oh,
write R in terms of 3/5 of height. I'll get one parameter, volume in terms
yeah.
of height.
And you
Volume.
solve for H, right, sir?
And then you find a derivative and get dSdt. You get the idea.
Yeah.
So dVdt is known to you because the tank is being filled at the rate of 1.8 meter per cube. This is dVdt. You get it?
Yeah.
And you know this equation dSdt, you have to find other things we are given. We know the height and we can relate everything and get the you now you understand the concept. You get the idea?
Yeah.
So the beauty of these questions is basically to understand what is really required. And as we will let's go back to our strategy once again before we get into the solution. Can you please read this again now?
Yes, sir. In related rates applications, rate of change of one quantity is given, and we are interested in finding the rate of change of a related quantity. First step to solve these problems is to identify what is given, what can be derived, and what is required. Then we find the equation that relates the two given quantities. If necessary, eliminate one of the variables, apply chain rule to differentiate both sides with respect to time, solve for the unknown rate by substituting the results obtained, and write the solution including units.
Including. Is that clear to you? Now
Yes,
we'll
sir.
see the first example. Now, if I show you this is a solved example, anyway, let's discuss the example. You have understood the concept, right?
Yeah.
So, what we were saying here is that a stone is dropped, and that is how it is increasing, correct?
Yes, sir.
And we understand that we at a particular instant where r equals to, can you please read the question once again?
Yes, sir. A pebble dropped in a pond produces waves that spread at a constant rate of 1.5 meters per second.
Correct.
Find rate of increase of area of the circle when the radius is 10 meters.
Right. So when radius is 10, we have to find increase of area, correct? So
Yeah.
now see how easy it becomes once you understand the question. It's not very difficult. So we know
Yeah.
area is pi r square, we know that, right? What
Right.
are we given? We are given the rate of increase in the radius, which is 1.5 meters per second, right?
Yeah.
You have to go with the units. And what we need to find is rate of change of area when the radius is 10, right?
Yeah.
So this is our question. So clearly, since A is pi r square, we know dA dt is 2 pi r times dr dt, right? You understand the
Yeah.
change? So we know dA dt at r equals to 10, just substitute r equals to 10 and dr dt is given to you, right? Dr dt is 1.5
1.5. Yeah.
and then plug in 10 and get your answer. So simple as
Oh,
that.
okay.
You find the answer. Sometimes they will ask you exact values. Then 30 pi will be your exact value in the answer. Is that clear to you?
Yes, sir.
So
Clear.
that is the way to do it. Now we have shown the solution in two different ways because you could apply the chain rule, right, directly. So look at the chain rule and the beauty of the solution. Let's appreciate that, right? So we know the two equations. Area is pi r square, and we know that d. Now, if I differentiate with respect to r, I'm not differentiating with respect to t. You see that?
Yeah.
With respect to r, it is 2 pi r. So I know dA dr. What do I
Yeah.
what I want to find is dA dt, correct?
Right.
Understand? So we want to find dA dt. That should be dA dr times dr dt.
DRDT. Yeah.
Dr dt is already given to us.
Yeah, it's 1.5.
So we have even avoided to write one function into another function or
Yeah.
eliminate a variable. Straight away, we knew that A is equal to pi r square. So I could differentiate with respect to r, right?
Yeah.
And 2 pi r. So I get dA dr with that. So I know
2
this,
pi r.
and this is given to me. So I have the answer. You get the idea.
Oh, wow. Yeah.
We have got the answer. So this is the beauty. And so we can just substitute and get the same answer as we got in the first case. Perfect.
Yes, sir.
So when you get a question, it is not necessary to write one variable in terms of the other. You can use this
Yeah.
concept, right? For
Yes,
example,
sir.
we'll go through this, but I mean, this is a very simple question. However, it gives you such an important strategy to work with. That's the beauty
Yeah.
of this question. Is that okay? And that's why I've taken it as the very first question and explained you with both the methods, right? Let's look into the second example now.
Yes, sir.
Read the question.
The volume of a spherical snowball of radius r is V equals 4 by 3 pi r cubed.
So we are
A
given this.
snow,
We have made this recording. Yeah,
yeah,
continue.
a snowball is melting such that its radius is decreasing at the rate of 0.025 centimeters per second.
Now look here. As soon as you
Oh,
see it
okay.
decreasing, as soon as you see
Yeah.
it decreasing, minus 0.025 decreasing. You get the idea?
And that would be
Instead of it is
the
negative.
radius, right, sir?
Yeah. So
Okay.
a snowball is melting such that the radius is decreasing at the rate of. So dr dt is minus whatever the value is given to you, correct? So
Yes,
as
sir.
you read the question, translate into your equation what is given and what you need to find out. And then, can you please read the next part? Find what?
Find the rate of change of volume with respect to time. So dv by dt
Correct.
when the radius is 2 centimeters.
When r equals to. Do you see how I have simply translated each and every given things and what do we
Yeah.
find in one sentence? Do you see that part? This is most
Yes,
important.
sir.
Split it and put it right in front of you. Then you see how do I solve? Not dv dt. I know the volume. Now, one of concept is I know dr dt. So what I have, so again, I'm using two methods, method one and method two.
Yeah.
Correct? You could follow any method. So in method one, I know the volume 4 by 3 pi r cube. I differentiate with respect to time. This is implicit differentiation. I'm
Yeah.
differentiating with respect to time. And given dv dt, I mean, I have to find dv dt, but given dr dt. So I get 4 pi r squared dr dt. In this, everything is given to me, and I have to substitute r equals to 2 and get my answer. Very simple, clear. On the other hand, I'm differentiating with respect to radius. Do you see that? And using the chain rule. dv dt is dv dr times dr.
Oh, okay. Yeah. So, sir, even in the multiplication, you can see that dr and dr cancel out, leaving you just dv by dt.
Yes, dv dt. So this is chain rule.
Yeah.
This is what chain rule is, correct?
Right.
No, we do not say cancel out, but this is the chain rule, right? So
Okay. Yeah. Yeah.
one into the other, it follows, right? It is function of
Yeah.
one. So inside out we work. Now clearly, independently we are already given dr dt, right?
Yeah.
Which is negative, right? I should have written negative here, which is negative. I should have written negative here, right?
Yeah.
Everywhere. So, but find the rate of change of volume with respect to this. In that case, I should say it is decreasing at this rate. You get the idea? Or I
Yes,
will
sir.
write negative. Or you add the word decreasing at this rate. Is that okay?
So you'd get a negative final answer, right, sir?
Yes. You should have. I should have put negative because this is negative, right?
Yeah.
So I'll put negative here and get a negative final answer. And the volume changing with time, meter cube over second. Is that clear to you?
Yes, sir. Clear.
So you could adopt any of these methods. Very, very important questions, right? Now,
Yeah.
question number 3. Yes. Can you please read this question?
Yeah. The surface area of a sphere of radius r is expanding at the rate of 0.05 centimeters per second. Find the rate of change of area with respect to time when the area is pi centimeters squared.
So the strategies again, what are
Yeah.
you given? You're given that the area formula is 4 pi r squared. You know that area, right? Because surface area is surface area of a sphere you're talking about. And you're given the area
Yes, sir.
formula 4 pi r squared. Now it says it is expanding at the rate of 0.05 centimeter per second. So radius is increasing at this rate. Positive. Is that okay?
So dr by dt, right, sir?
dr by dt. And you need to find dA by dt at a equals to pi. So you have
Okay.
written that all together. Now you know your equations, you know dA dt. You can follow either of these two methods. Clear?
Clear, sir.
Easy? So
Yeah.
this process, if you understand, then depending on the question, you could choose your method of operation. You get the idea?
Yes, sir. I think I'm a bit more comfortable with chain rule because the
Yes.
extended power rule has implicit differentiation too, right? So,
Correct.
yeah.
Very easy. Chain rule is very easy. And see, many students do not use chain rule in this case. And I'm actually promoting that.
Yeah.
Always taking up that as my second method and showing you how simple it is. One part is already done for you. You get the idea?
Yeah. Yeah.
Part is already done for you. You are given DRDT. Why not use it directly?
Exactly.
Why to mix it up? So use it
Yeah.
directly, and then this is a direct derivation, first one, and get
Yeah.
your okay. Got the
Yeah.
idea? Okay.
Got it, sir.
So the question is not difficult so far, but it gives you very good strategy. Next question, please. Can you please read it?
Yes, sir. Tap is filling water in a container at the rate of 240 centimeter cube per second, and the level rises at a rate of 0.8 centimeters per second. How fast is the volume changing for each centimeter increase in height?
So we have to now find dVdh. You get the idea? We have to
Yeah.
find dVdh. So slightly tricky. So if you see, the rate is being seen as dV/dt, rate with respect to
Rate,
time.
yeah.
So see the beauty of this question. It is actually it's a thinking question. It looks very simple
Yeah.
on salt paper, but look here. We have dV/dt. I'm using the chain rule, right? Because now,
Yeah.
as actually you said, chain rule is better. We'll work with chain rule. So
Yeah.
dV/dt is dV/dh times dH.
DHDT.
What do we need to find? We need to
DVDH.
find dV/dh. You get the idea?
Okay. Yeah.
And if you look at it, we know this and we know this. So we can
Yeah.
divide this by that and get the answer.
Yeah.
So it's a thinking question. It's very simple question provided you hit the nail at the right time, at the right place. You get the idea?
Yes, sir.
And
For this one, we just have to rearrange a bit. Right?
just rearrange, isolating
Yeah.
a variable kind of thing, and rearrange the formula, making dVdh as your subject, and you find the answer.
Right. Yeah.
Otherwise, you start thinking like, no shape is given, and how should I begin with?
Yeah.
What formula to use, right? No formula.
Yeah.
Use chain rule.
Right.
So if you do not use effectively chain rule, you cannot actually do this question. You get the idea?
Correct. Chain
For
rule is the only method for this question, right, sir?
this question, you have no alternative solution. I
Yeah.
mean, that is the solution. Last question is slightly more cumbersome, but we'll see how. The
Yeah.
idea of having this question is how do we write one variable in terms of the other, modify
Correct.
our equations as I described earlier in the beginning,
Yeah.
steps, and then do a question. Most of the questions are done in this fashion. Is it okay?
Yes,
Can
sir.
you read this question?
Yeah. Example 5, right circular cone. Water is being pumped in the circular cone shaped tank at the rate of 1.8 meter cube per minute. This 5-meter high tank has 6-meter diameter at the top. Find the rate at which the water level is rising when the water is 2 meters deep.
Got it. Now tell me, how will you attempt this question?
Sir, so first I would see what they want us to find, which is dH by dt
Yes.
when h is equal to 2. And
Right.
then I can see that they gave us meter cube per minute, which would be dV by dt,
Correct.
1.8, and
Right.
then the volume of the cone would
Circular
be
cone.
pi
So
r squared h over 3.
wow. Yes. So you, because they have mentioned circular cone, it's a good idea to draw a diagram for that. Cross
Yeah,
section is very beautiful, neat diagram as we have shown here. They've already given 6 as the diameter, so I mentioned 3 as radius, right? And
right,
height is given to us 5, so we know this height. And as I told you in the beginning, sometime in between, when it is 2 meter, we have to find. But in general, the water level is rising. So in general,
right,
rising with radius, different radius, and height is also changing. These two things are changing.
yeah,
Perfect. So in our formula, 1 by 3 pi r square h, both r and h are changing.
yeah,
Both are changing. Since we are interested in dh dt, we have to eliminate r.
right. Rewrite it, right, sir?
So similar triangle concept, right? So we say, well, this big triangle is
Yeah,
similar to this small triangle, right? And so we have our equation r over h is 3 over 5. So we have related r and h, right?
okay, yeah,
R is equal to 3/5 of height. And therefore, in the formula, which was 1 by 3 pi r square h, I replaced r with 3 by 5 h. Do you see that?
yes, sir,
So we have now an equation which relates volume with height. So volume as a function of height, straight.
yeah,
Now if I find dv dt, I have dh dt on the other side because height is the other variable, right?
okay, yeah. So this is implicit, right, sir?
Yes. And then
Yeah,
I could uh, cross multiply and get dh dt, right? Divide this by this and get the answer. You see
right,
the solution now?
yes, sir.
Get the idea? So that is how we could actually solve this particular question, right?
So there's no chain rule to this, right,
No,
sir?
no, you could apply chain rule.
Okay,
You could
yeah,
apply chain rule because we know what we really want to find dv dt, right? So we have dv dt
yeah,
is equals to dv dh, dh
yeah,
dt. You see that?
yes,
dv
sir.
dh and dh dt, right? So we could do it. So straight away from here we could find dv dh.
Yeah,
I mean, once you have done this dv dh, I mean this place, because this is an edge, right?
right. Okay,
And then
because we
you
have
can
to
find
rewrite
the
it
edge.
first.
But the amount of effort is almost same because we had to
Yeah,
convert one radius into that. So it will be
right.
the same effort, right? You
Yeah,
could use chain rule directly also. No problem. You could do that, right?
yes, sir.
Okay. Now, chain rule, you could use a, yeah. So in this particular case, you could also use chain rule with R, H, and V. So there could be a
Yeah,
longer chain rule also because we could relate this equation, dr, dh also we could relate, right? But the
right.
approach which is given to you is the simplest one.
Yes, sir.
So when it becomes too many elements, then chain rule becomes slightly more complex.
Yeah,
So in that case, better simplify the formula. So in this case, what are we doing? We are we are we write as a volume as a function of height. You get the idea now. Instead of
yes,
two
sir.
variables, we reduce it to one.
One
Earlier we
variable
were saying volume was a function of r and h.
and h.
So
Yeah,
we simplified that equation. Then it is just a question of volume and height relation, right?
yeah. So then it's just a one variable function, right? So
Hence one variable. It is easier for you at this stage to solve,
yeah,
right? Because we are not very conversant with two variable problem solving at
yeah,
present, right? You learn that in university very easily. So just
yeah.
isolate. So does that make sense to you,
Yes, sir. Makes sense.
right? So with that, we have understood our strategy and we also seen some beautiful questions answered. So we'll end our class here. Akshit, can you share the learnings?
Yes, sir, for sure. So today we actually started with the applications of the derivatives. So actually, when I saw the chain rule, I thought we can only apply it to questions like where we were given a function in terms of dy du and then du dx. But I never thought that I can actually apply to a word problem where I have to pick out which derivative is given by the units.
Yes.
So I think that this type of question will definitely be appearing on the test. So now that I'm practicing it from now, hopefully I can solve the next test just as accurately and fast as the one before.
Sure. Yes, I hope so. Yes, that's good. Great,
Yeah.
Ashish. You'll end the class. Practice some more questions from my playlist. Just type
Yes,
out
sir, for sure.
application of derivatives and you'll come across
Yeah.
many. Let me also tell you, in most of my videos, I have not used both the methods, right? So
Yeah.
try using chain rule to solve my questions. That'll be wonderful. Okay?
Okay.
Okay, great. Thanks. And
Okay.
all the
Thank you
best.
so much, sir.
My pleasure.